Alright, so now moving on to the elementary charge of a particle. So the smallest amount of a charge, the elementary charge, is that on one electron. It is called the elementary charge. And here is the value of that elementary charge. So it's, for an electron, it's a negative 1.6 times 10 to the negative 19. And this C stands for Coulombs, which is the SI unit for charge. The note here, it just says that a proton has the same magnitude of charge as an electron, same magnitude of charge as an electron, but is positively charged, as we said in the previous video. And sometimes denoted as E plus, and sometimes an electron is denoted as E minus. Okay, so the SI unit, that's like I said, the SI unit of charge is the Coulomb, and it's C, and 1 Coulomb is equivalent to 6.242 times 10 to the 18 elementary charges. So that's 6.242 billion electrons, essentially. And we can work out the number of electrons, or excess electrons, by E is equal to Q, or number of electrons is equal to Q, so the charge, over 1.6 times 10 to the negative 19, so the charge over the charge of one elementary charge. Just remembering that if it's an electron, then that is going to be a negative sign down there, which we'll see right now in an example. So I have an example. A plastic ruler has a charge of negative 1.5 nanocoulombs. How many excess electrons are on the ruler? And so if you want to try this one at home, you need some sort of fur, there's some sort of other kind of material, and if you rub on that ruler, then you might be able to build up a charge. Or you could try rubbing a balloon on your hair, and you can see some hair sticking up like that. So you can try some static electricity problems at home. And I mentioned before you might have experienced electric shocks before. But anyway, so we got the number of electrons is equal to the charge, so it's negative 1.5. And remember from our prefixes, then N is times 10 to the negative 9 coulombs, all over, it's going to be a negative 1.60 times 10 to the negative 19. And that negative just comes into it, so their signs cancel out. And that is equal to 9.375 times 10 to the 9 electrons, which is equal to 9.375 billion electrons. Okay, and I mentioned lightning in the previous video. So a Van de Graaff generator creates lightning, artificial lightning, little sparks that go through the air. So we'll just read through what lightning actually is. So a thundercloud can be several kilometers wide and well over 10 kilometers high. Different parts of the cloud become charged as a result of movement or collisions of ice particles of different temperature throughout the cloud. If there is a strong enough difference in charge between different regions of the cloud, or between the base of the cloud and the Earth, air molecules become ionized, so charged, that means charged, creating a flow of charge between the regions. This is lightning. So what can happen is if we have different regions inside the cloud, we can actually have lightning travel. Lightning often travels within the cloud, so it doesn't always just happen to be between the cloud and the Earth. So what can happen here is if we get a build-up of negative charges down the base of the cloud, then positive charges in the Earth, or the Earth will rise to the surface, and then when the difference in energy is large enough, the energy will dissipate down through to the Earth by ionizing the air. Okay, and that energy, it gets dissipated in the Earth, but it also comes out as obviously heat and sound, because we hear the thunder, and we see the light from the lightning. And sometimes if you see burnt out trees caused by lightning, then it obviously comes out as heat as well. So when the energy dissipates, it does transform into other forms of energy, just like we saw before.